Assalamualaikum dan salam sejahtera to all students. So today we're going to learn chapter 3, wave. This week's I will going to cover from 3.1 to 3.3 contents only. For 3.4 until 3.7 we'll cover by next week's. Characteristic of wave is a pulse caused by a disturbance in a medium. As you can see in the figure, so the force applied here, the cohesive force between adjacent part cause the adjacent part cause the wave. When the disturbance continuous and oscillating or continuous or periodic wave is produced. So from the figure here, there are two parameters we can obtain. First one is amplitude. Amplitude is the maximum height. Okay, all these are amplitudes. And this is known as a crest or peak, and this one known as a throw. So as you can see here, when two successive parts meet, which is known as crest to crest, so we can measure a lambda wavelength, or we can measure by using a throw. Throw meet with throw, so we can measure a lambda. It's whether you want to measure the lambda from crest point to crest point or from the throw point to throw point. It depends on you. Let's proceed with important parameter you should know in this wave, in this subtopic. First one is amplitude. As I mentioned earlier, is the maximum height of a crest or depth of a throw relative to the normal. So the unit is normally cm or meter. So the wavelength is the distance between two successive identical points on the wave. For example, distance between two successive crests. The unit is centimeter or meter. It depends on the question given. Frequency F is the number of complete cycle per unit time. The unit is a hertz or per second. Period T is the time required for one complete oscillation. T equal to 1 over F. So the unit is second. Wave velocity, the velocity at which any part of the wave, or for example, crest move. V equal to F lambda. So the unit is meter per second. Proceed with important parameter you should know. So again, for velocity, speed of wave on chord. Chord is normally related to the tension. The speed of wave having the same amplitude on a string or chord. So as you can see here, equal to square root of Ft divided by mass per length. So mass in kg, F in Newton, length in meter. So now let's see at the graphical representation. So there are two types of graph in this chapter for wave. First one is displacement versus distance graph. From the graph here, we can obtain three parameters. First one is displacement y. As you can see, displacement versus distance. So y, and amplitude is a. How to find the amplitude? So we take the maximum height here. Wavelength, as I mentioned earlier, from the crest to crest, or from the throw to throw, or one complete oscillation. For example, okay, as you can see here, if let's say you start at here at 0, so if let's say you start here, so then from this point and end here, so we can find the wavelength here. Or either you can use this part to this part. Also, we can find a lambda here. Okay, this is amplitude. Above, upper or below, it depends on you which one you want to take, as long as you know. Displacement. Second one is displacement versus time graph. So from this graph we can obtain a amplitude. Okay, same goes here. Is maximum height. The period is the one time taken for one complete oscillation. So here starting point and complete oscillation is stop at here. Alright, similar to wavelength. So then This is the period. We can find the period. Or you also can measure from throw to throw or from the crest to crest. So we will get period too. It depends which one you want to measure. So remember for the period, make sure the graph is displacement versus with the time. Example. Determine the amplitude and wavelength of the wave. As you can see, the first graph. First graph shows the graph displacement versus distance. Alright, so the amplitude, how to find the amplitude? Amplitude is maximum height. Height here is 20. So the amplitude equal to 20 centimeter. How about wavelength? So how to find the wavelength? So as I mentioned, you can take a point from throw to throw. Or you can take from the starting point here and stop at one complete oscillation. Let's see what is the value. 0, 15, so the gap difference is 15, 20, 30, 45 and 60. So the wavelength is 60 centimeter. Agree class? Clear? Or let's check by using a pick point or throw point. So here 15, here is 75 centimeter. So the distance here is 75 minus with 15. So we got is the value is 60 cm. So the wavelength is 60 cm. Let's proceed with the second example. Determine the amplitude and period of the wave. As you can see here, the graph represents y versus t, displacement versus time. So amplitude same, which is a 20 centimeter because the height maximum is 20 centimeter. How about period? One complete oscillation. The starting point here is here and stop at. What do you think? What is the value here? 5, 10. So the gap is 5. The increment is by 5. 5, 10, 15 and 20 centimeter. So the period is 20 seconds. Agree class? Alright. Make sure if you don't understand, make sure you listen again and again. Type of wave. There are two types of wave. For this one, two things you need to consider. First one is the definition of wave. The second one is the is the example of wave. Transverse wave is the motion of the wave particle are perpendicular or transverse to the propagation of the wave. For example, wave on the water, on cord, on land, as you can see in the figure. Longitudinal wave is the wave motion of the wave particle is the parallel to the propagation of the wave. As you can see in the figure, it's parallel. So for example, sound wave. As you can see, example there. Next one, mathematical representation of a wave. For this one, consider a one-dimensional wave traveling along the x-axis. As you can see in the figure, there are d versus x. Right, d versus x. Okay, this is along the wave traveling at t equal to 0. At t equal to 0 here, okay, yx 0. 0 means that t equal to 0. Right, so a sine 2 pi divided by lambda x. 2 pi divided by lambda is represent the constant. Constant in simple harmonic motion, which is equal to k x. K. Sinusoidal wave moving in the positive x direction. Right, so let's see at the equation here. Suppose the wave moves to the right. As you can see, it moves to the right at velocity v. At t second letter, at the time equal to t second letter. Okay, so then a sine 2 pi divided by lambda x minus v. t, x minus with t, because of the wave here traveling with x divided by vt. Vt is the distance traveled by the wave. And simplify the equation here. We know that v equal to f lambda. Substitute the f lambda in here. So then simplify the equation. We got the t. Summarize the 2 pi here. Then we got the x divided by lambda. T divided by the t, capital letter of t represent the period. Then y, simplify again by substitute the equation omega equal to 2 pi f. Then we got the equation, general equation of the wave travel, which equal to a sine kx minus omega t. K is the wave number and omega is the angular frequency. Kx minus omega t represent the pace. Therefore, for displacement y as a function of distance x and time t, we got the equation here as I showed earlier. 3 equation and simplify, then we got this equation. This is general equation as a function of x and t. And as you can see, there are positive, negative here. Positive, negative represent wave traveling to the left for positive, and negative represent wave traveling to the right for negative. Wave number is a k equal to 2 pi divided by lambda. The unit is radian per meter. Angular frequency omega, unit is radian per second. Omega equal to 2 pi f. Okay, the period t is in second, 2 pi divided by omega, or equal to t1 over f. Pace is a kx plus minus omega t. Unit for pace is radian. Pace is the angle. Pace speed, v. There are 4 equations of pace. It depends on the information given from the question given. First one is distance traveled divided by the time, or you can use a lambda divided by period, f lambda, or omega divided by k. K is a constant. What if the displacement is not 0 at t equal to 0? Then we generally express the wave in the form y x t in the function of x and t equal to a sine kx minus omega t plus psi. So the difference is here we just add plus psi. Okay, because of at t equal to 0, the displacement is not 0. That's why plus psi here. Pace psi is a pace constant. From the graph here, as you can see, the psi is traveling to the right. So then, that is why we put a plus here. Don't confuse with this sign. This sign is represent negative, represent wave traveling to the right. Psi and positive sign and negative sign here is different. This one for psi. This is summary of the wave equation. There are 2 summary. Okay, the first one, at t equal to 0 second, x equal to 0 meter, the equation is y xt a equal to a sine kx plus minus omega t plus minus psi. Remember, plus minus represent the wave travel to the right or to the left. If let's say the question asks for the velocity, we just integrate from the equation of displacement here, so we can find the v. You have already learned how to get this equation in part 1, if I'm not mistaken. So then we integrate, we got the a omega, then sine change to cos, kx plus minus omega t plus minus psi. Psi, if there are psi, if x is not at 0. But we need to put the psi here because this is general equation. Alright, so then if let's say the question asks for the acceleration, so we just integrate the v here. So we got the equation. Cos integrate, we will get negative sign. So that's why they are negative here. Negative a omega squared sine kx plus minus omega t plus minus psi. So this graph represents the sine graph because the displacement is start from sine. So as you can see, it start at t equal to 0, x also equal to 0. Then the second graph represent the cosine, sorry, the cos graph. Because of at t equal to 0, x is at a meter, which is at the maximum height and amplitude. So we use the equation vxt a cos. Because at t equal to 0, but the x is not at 0, x already at a meter, maximum height. So plus cos ka cos kx plus minus omega t plus minus psi. Same goes here. If let's say the question asks for the velocity, then we just integrate from the equation of displacement. So we got the velocity equal to negative. Why negative? When we integrate the sine, the cos, so we get the negative sine. Then negative a omega sine kx plus minus omega t plus minus psi. And acceleration, integrate again from the velocities, we get negative sine change to cos a omega squared cos kx plus minus omega t plus minus psi. Then let's proceed with example. A sinusoidal wave traveling in the positive x direction. Highlight the information given. Positive x direction has an amplitude of 15 centimeter. Okay, wavelength 40 centimeter and frequency 8 Hz. The vertical displacement y of the medium at t equal to 0, x equal to 0 is also 15 centimeter. In A, you need to find the angular wave number, k, period t, angular frequency, omega, and speed of the wave. The second one, first one is k, which is a wave number equal to 2 pi divided by lambda. 2 pi is a constant. Lambda already given in the question. So then just substitute 40 centimeter here. So we got the radian in 0.175 radian per centimeter. Centimeter here because the lambda is centimeter. Omega 2 pi f. F already given. So 8 per second. So substitute, we got the 50.3 radian per second. For period equal to 1 over f or to omega f, sorry, t equal to 1 over f. So just substitute the f here. So we got the value of period. V equal to f lambda. F is from here given already 8 per second time with lambda 40 centimeters. So you got the velocity 320 centimeter per second because lambda is given in centimeter. Then we need to find the pace constant and wave function. So because of A is given 50 centimeter and Y is given 15 centimeter also at L equal to 0, T equal to 0. So refer to the function equation, which is Y equal to A sine kx minus omega t plus psi. The question asks for the psi, so we need to put the psi equation in here, even though the x equal to 0, t equal to 0. So then, here, Y, we substitute the value of Y, 15, and A, 15. K we found in part A, but K here is supposed to be 0.157. There are typo error here, so just substitute again. You try to calculate by your own. Time with 0, so we get 0. 50.3 time with 0, we got 0 plus with psi. So then shift sin 1, so we got a psi equal to 90 degree, which is equal to pi over 2. Pi over 2 is 90 degree. So then we can find the wave function. Substitute all the information we have. 15 amplitudes A sine kx minus omega t plus with psi. So this is the equation. Right? let's try another example. This one you need to solve by your own. I just give you the hint how to solve the equation. A transverse traveling wave on a chord is represented by t 0.22 sine 5.6x plus with 34t. So compare to the general equation. So then you know what is a 0.22, what is a 5.6, what is a 34. Positive here means that the wave traveling to the left, where the are D and X are in meters and T in second. So for this wave, determine the wavelength. So how to find the wavelength? Wavelength equal to 2 pi. Sorry, the wavelength you can use the equation of K equal to 2 pi divided by lambda. K already given in the information up there. So just substitute all the information. K 5.6 here. So you can find 2 pi is constant, so you can find lambda. Frequency, to the information from here, 34. 34 represent the lambda, so you can find the lambda because, sorry, you can find the omega. Here is 34 is omega. So you can find the omega equal to 2 pi f. So then you can find the frequency. The velocity equal to f lambda. F from part 2, lambda from part 1. So you can find the velocity. Amplitude, this is amplitude, 0.22, is it? Are you agree with me, class? And the last one is the maximum and minimum speed of particle of the chord. So how to find the maximum and minimum speed? Okay, try by your own. The second next example is a progressive wave on a string is represented by the equation y 6 sine 200t minus with 10x minus here representing wave is traveling to the right, where x and y are in meters and t in second. Compute the speed of particle of the string at x equal to 20 meter and t equal to 2 seconds. Compute the speed. The question asks for the speed. As you can see here, given x at 20 meter and t at 2 seconds already, this means that you need to use the equation of velocity in the function of x and t, which is v equal to a omega cos sine k minus omega t. So took all the information here, so you can find the speed and substitute the x value and t value in this equation. Okay, good luck. Alright, the last subtopic for today is energy transport. Okay, for a sinusoidal wave of frequency f, the particle move in a simple harmonic motion and each particle has energy, as you can see in the figure. So the energy, when there are velocity here, there are energy. So L here represent the distance travel equal to VT, and A prime, as you can see, the prime here represent the area. Okay, for energy transport by a wave is proportional to the square of the amplitude. So energy in joule equal to half Ka square. A is the amplitude because the square of the amplitude here mentioned already. And then we expand the K from the information here, from the equation here, expand the K. So K, derive the K. So K equal to 4 pi square F square times with M. So we got K. So substitute in here, simplify 4 divided by half. So we got 2 pi square M F square A square. Alright. M is the mass of particle. Okay. For a 3D wave traveling in an elastic medium, assuming the entire medium has the uniform density R. So let's have a look. M is equal to rho V. Rho is the density, V is the volume. Equal to rho A prime times L. A prime is represent the area. And if let's say there are no L given, so we substitute L by the L equal to Vt, represent the length, which is time with V time with time. So substitute all the information into the M from the equation of energy. So this is M equal to 2 pi E energy equal to 2 pi squared rho A prime V velocity time with T F squared A squared. A here represent the amplitude. Therefore, the energy transported by a wave is proportional to the square of frequency and square of the amplitude, as you can see in the equation here. Then energy over time is the average power. The power is, unit of the power is watt. So just put the equation of energy divided by the time. As you can see here, the missing information, I focus on the missing information only. So take all the information, all the equation of the energy, and then we divide by the time. But I just focus on this S and T. So I just took the missing information from the equation of energy, S. How come, where is S come from? So actually S is equal to energy divided by the time. Actually in previous equation there are A prime times with T and divide by T. T here is when the energy divided by the time. So I suppose here there are 2 pi square rho V F square A square, but I just focus on this. Again, I mentioned I just focus on this because I want to show how the S replace, how the S get here. So then we just cancel out the T, so only A prime left here. Then we replace the A prime with S. So that's why we got this equation. Next one, intensity. Intensity equal to energy divided by the time. So we already find the power from the energy divided by the time. Then divide again by the area to find the intensity. So we just took this equation, or this equation here. Okay, then I just focus on A. I just took the A. Okay, so then took the equation here. All the energy power here just divide by the A area, A prime. So then the area here, as I mentioned, I show you here earlier, represented by S. So we can cancel out A prime S. So that is why we got this equation for intensity. So from the equation, we know that intensity is also proportional to the square of the amplitude. Therefore, intensity decrease with distance and amplitude of the wave will also decrease with the distance. Alright, that's all for part 1, chapter 2. I will proceed with part 2 from 3.4 to 3.7 by next week. Thank you for listening to me and enjoy the lecture. And if let's say you not understand some of the lecture given by today, you can ask your lecturers. Bye bye. See you again.